Good morning, Honors Pre-Calculus students. We're going to go ahead and get started with a problem of the day. So this is your warm-up problem. What I'd like you to do is just wherever you're about to take notes or at the end of your homework, whichever you prefer, just go ahead and get started on this problem. What I'd like you to do is take this graph down here. I want you to do two things. I want you to identify the domain and range. And I would like you to identify the intervals of increasing and decreasing. Please take note that these answers will both be an interval notation. Okay, so I'll give you a couple moments to work on that. Okay, as a class, if you'd like a couple more minutes, go ahead and press pause, whoever's in charge of playing the video. Otherwise, I'm going to go ahead and move forward. So when you're ready, just press play. So first of all, let's talk about the domain and range. The domain is where we have x values. So it looks like we begin at this coordinate and end at this coordinate. So this first purple coordinate has an x value of -2.5, and it would be included. And then it stops at an x coordinate of 3 with a closed circle, so we can include it. Okay, then when we look at our range, our y values, it looks like our lowest coordinate is here, and we have a tie for our highest coordinate up here. So our range is going to stretch all the way down to from -10 and all the way up to 16, and we would want to include both of those numbers as well. Okay, now for our intervals of increasing and decreasing, okay, remember we need to look at the pieces of the domain in which we have those. So first let's start with increasing, and I'll identify those in red. So it looks like there are two pieces. This piece right here is increasing, so I would describe the x values as from -2.5 to -2. And then again, we have this right here, which goes from 0 to 2. Okay. Remember, we're using parentheses, and we're going to union any intervals together that are a group. Okay. Oops. So then in blue, I'm going to go ahead and identify decreasing intervals. Our first decreasing interval looks like it's right here. It starts at -2 and stretches to 0. Okay, remember we're looking at the x values here. And then our second decreasing interval is here. So it looks like it starts at an x value of 2 and ends down here at an x value of 3. So there's our decreasing interval. Okay. Okay, so what we're going to do today is we're going to go ahead and continue in section 1.5. We're going to talk about a number of things again. This section of chapter 1 has a lot of review pieces, and today we will talk about something that, one thing that will be new for you. Okay, so review item number 1 is this concept of average rate of change. Okay. Rate of change, we like to associate with the word slope. Okay, so we are looking for average slope, okay? If I gave you a linear function and I said identify the slope, you would all have an okay time figuring that out. All linear functions except for a vertical line have slope. Now, if we are talking about a nonlinear function like a parabola or a cubic function, those don't have a constant slope like a line does, so we have to measure what's called average rate of change. So the average rate of change is what we call the slope of the secant line between 2 points of a function. So I'll let you go ahead and copy that down. Here is the definition. So what's happening is we have a nonlinear function and we have two coordinates. And when we take those two coordinates and we draw a line through them, that's called a secant line. And when we find the slope of that line, that is what we call our average rate of change. We're finding the slope between 2 points to describe a non-constant change between 2 points on a nonlinear function, okay? How do we find slope? Let's remember from our quiz that you are turning in tomorrow that we need to take the change in y's over the change in x's, okay? So basically, when you see average rate of change, okay, first of all, rate of change, I want you to think of slope, okay? And so average rate of change, you should just associate that with, hey, I need to find the slope between 2 points, okay? So let's go ahead and try that. Here we have the average rate of change between 1 and 5, okay, of our function x squared plus 2x plus 8. I should probably remind you that you do need a graphing calculator for this class. We are going to use it as a tool to help us as we prepare in Chapter 1, but our Chapter 1 test will be non-calculator. So as we go through these examples, keep that in mind that we are going to be doing this without a calculator. So our average rate of change, and I'm just going to say average rate of change, is just the slope between our 2 points. So we need to calculate our function at 5 minus our function at 1 all over 5 minus 1. Okay, so the function at 5 is 23 minus our function at 1 is 7 all over 5 minus 1. So we have 16 over 4, which gives us 4 as an average rate of change. What's happening is we have a parabola, and when we take x is 1 and x is 5, our average rate of change, or the slope between those 2 points, is 4. Okay, so here's a problem I'd like you to go ahead and do without me. Find the average rate of change for this function on this interval. So I'm giving you an interval, which basically just means, Okay, here's where we start. Here's where we stop. Okay, I hope you're arriving to the answer of 2, just like I have up here. We have our change in y, 10 minus 0, over our change in x, 4 minus negative 1, which gets us 10 over 5, which is 2. Okay. The next set of definitions is what's going to be new to you in this chapter. We're going to talk about the difference between an even function and an odd function. And you need to be able to determine an even function versus an odd function, both algebraically and graphically. Okay? This will help you with that green sheet that you're supposed to be filling out. For each of the parent functions, you're supposed to determine if it's even or odd. On your parent function sheet, looking at the graph is going to be a great way to determine even versus odd. Okay? But there are some of these that I need you to prove algebraically, so we're going to go through both. So first, we have an even function. So an even function, the first thing you need to know is that f of negative x equals f of x. That's going to be the algebraic definition. Okay? An even function means that f of negative x equals f of x. Okay? Well, what does that mean? That means that our outputs for x are the same as our outputs for negative x. So we are going to have symmetry along the y-axis because x and negative x will have the same y coordinates. X and negative x, x and negative x will have the same y coordinates. So we're going to have symmetry about the y-axis. So graphically, if you can take the y-axis and you can fold your graph and it looks the same on the right side as it does the left side, like this one, then you can say, okay, I know that this is an even function. If I ask you to prove algebraically that it is an even function, then that is when we're going to use the f of negative x equals f of x. Okay. Now, we have what's called an odd function. If we have even, we have to have odd also, right? So our odd function, once again, we're going to have 2 definitions here. So first, algebraically, an odd function means that f of negative x is the same as negative f of x. There's lots of notation here, so please make sure you get the negatives and the x's and the f's where they're supposed to go in the order that they need to be. Okay. Graphically, we are going to have symmetry about the origin. So basically what's happening is when we take f of x and we throw the negative in front of it, then that y value is the same as the y value when we put a negative x into our function, okay? That sounds really strange, I know. So if I'm talking about this coordinate right here, it has the opposite output of this right here, and the x's are opposite. So the x's and y's are opposite, which gives us the symmetry about the origin. So basically, we could fold along the y-axis and then fold along the x-axis, and then they would match up. Okay? So let's talk a little bit graphically about some functions that are even and odd. Okay? Even might be easier to think about right now. So on your 8 basic function chart, I want you to think of 1 or 2 of those that would be even. Our quadratic, y equals x squared, that's an even function. It has symmetry along the y-axis. What's another one? Did you say y equals the absolute value of x? Because that also has symmetry about the y-axis. Now let's come back to our odd functions. Our odd functions, excuse me, are symmetrical about the origin. So let's think about our 8 basic functions and which of those would be odd. Okay. Y equals x cubed would be one of them that is symmetrical about the origin, so it's an odd function, as well as y equals x. That one might not be as obvious. Maybe it is to you. But those are 2 examples of odd functions. These aren't the only 2 odd functions. I guess I don't have it in front of me, so it could be, but I can't guarantee it. I know for a fact that these 2 are not the only 2 even functions, okay? So make sure you go through and continue to look at those now that you know those definitions. So now, let's go ahead and talk about proving this algebraically. This is something, listen carefully, this is something I will be very, very picky about. If I ask you to prove algebraically whether a function is even or odd, then I am looking for number 1, algebra, and I'm looking to make sure that your algebra leads to either this or this, okay? So, we need to determine 3 things. We need to compare f of x and f of negative x if we're going to be even. If it's not even, then we need to look at negative f of x to compare it to this middle one to see if it is odd, okay? So these 2 right here will compare to help us determine even. These 2 will compare to help us to determine odd, okay? If you find one that works, don't worry about checking the other. A function can only be odd or even, not both, and it is not guaranteed that it will be either one. Most functions are neither, and so it's okay to get that also. It's just special if they are odd or even. So let's go ahead. We know that f of x is 4x squared minus 2. We know that f of negative x, well, that just means we're taking negative x and we're plugging it anywhere there is an x. So since there was an x right here, I replaced it with negative x. Okay, well, let's go ahead and reduce that. If we take negative x, the quantity squared, that just turns in to x squared because a negative to an even power will cancel out. Well, now look at what we have. We can see that f of x is 4x squared minus 2, f of negative x is 4x squared minus 2. So we have shown algebraically that f of x and f of negative x are equal, therefore our function is even. Okay. But notice how this is not all that I care about. Yes, that's the answer, but I care about the work, okay? This first part right here is given, but I need to see these pieces right here. I need to see your work that you thought about negative x and you plugged in negative x and simplified it, okay? So to wrap our heads around this a little bit more, let's try another one. Okay, here's our second example. We are talking about a function, f of x equals x squared minus x minus 6. Okay, so we know that f of x is x squared minus x minus 6. Let's go ahead and look at f of negative x. When we plug negative x in for x, make sure you do that with parentheses so you can really get an idea of what will cancel and what will not. So when we look at f of negative x, the quantity squared, will give us will give us x squared. Then when we take minus negative x, that will give us plus x, and then minus 6 gets to stay. Okay, so when we compare f of x and f of negative x, those are not the same. F of x does not equal f of negative x, so we know that it is not even. And I even want to see that. I want to see this that I just wrote and I'm putting arrows by. I'd like to see that, hey, I thought about it, Mrs. Homan, but it didn't work. Okay, I want to see your thought process with your algebra. Okay, I will say that again. I want to see your thought process with your algebra, which means I need to see all of your work. Okay, now let's look at, since those two didn't match up, let's think about negative f of x, okay? And negative f of x means we're taking our function x squared minus x minus 6, we're throwing it in parentheses, and we're putting a negative out front. Okay? Now, when we go ahead and we take that through, we get negative x squared plus x plus 6. We're just going to distribute that negative through. Now, I'll highlight this in yellow. Is negative f of x the same as this guy up here, f of negative x? These two do not look the same. So now we can conclude that since negative f of x is not the same as f of negative x, then it's also not odd. So our answer to this problem would be neither. Now, some of you might have been able to think about that graph and know right away it was going to be neither. But when I ask you to prove it algebraically, I need to see all of this work. There is nothing that I have up here that I would be okay with you leaving out. Okay? I want to see the work for f of negative x, and then I want you to compare f of x and f of negative x. Then I want to see the work for negative f of x, and then I want to see you compare the negative f of x and f of negative x. Okay. Okay, very quickly, we are going to refresh relative minimums and relative maximums, okay? And this is something that I sort of touched on, I think, yesterday in our lesson. And this is something that you would have talked about in Algebra 2. This is something that becomes very important in calculus. Now, when we have a graph like this, and you will recognize this graph from yesterday's notes, we can be very exact with where these relative minimums and maximums are. When we get to calculus, we have ways of getting exact when they're not so nice graphs. There are times where I would have you get your new graphing calculator out, and I would show you how to do this in your graphing calculator, but we're going to hold on and do that maybe at a different time. So if there is a problem or two in your homework that says use your calculator to find minimums and maximums, you do not need to worry about that. What I want you to do is I want you to find them when they give you a graph like I have here. So a minimum is a low point, but relative means just in the area. So anytime we switch directions and have a low point, we would have a relative minimum. So we have two coordinates here, and you're going to give me the coordinates. So in purple, I am labeling our relative minimums. This guy right here is the coordinate -3, 0. And this guy right here is the coordinate 3, 3. Those are our relative minimums. You will find a relative minimum anytime you have a switch from decreasing to increasing. Okay, now in pink, let's talk about relative maximums. A relative maximum is going to occur anytime we have a switch from increasing to decreasing. Okay, so a relative maximum means we have a high point in that area. So here, it looks like we only have one. We have a high point, and it turns out it is our highest point. It doesn't have to be. Okay, here 0, 3 is our relative maximum, but it's just anytime we have a relative high point. So let's just say I have a graph that looks like this. Okay, we would actually have 3 relative maximums anytime we have that change of direction and we have a high point. It doesn't have to be the highest point of the entire graph, just in that area. So we would have 3 relative maximums in this graph that I just drew. Okay. Okay, so a couple reminders. Tomorrow, your quiz is due. Please do not staple it, but I will need both the quiz and the yellow sheet. If I don't have your quiz, I don't know how many points I take off. I took off originally, so I don't know how many points to give back to you. So at the beginning of class tomorrow, if you did quiz corrections, then I need you to have those ready to turn in together, yellow sheet on top, then the quiz. Okay? Also, you have a book assignment for tonight. If you haven't tried Calc Chat to check your odd answers, please do that. And then keep working on your 8 basic function chart. I will have a key on Thursday so you know that you have the right functions. And in tomorrow's lesson, I will reference it a little bit more also. Okay? Any remainder of the time, if you are in class, can be used to begin your homework assignment. You can access the book, Chapter 1, in the Google Classroom right at the top on Chapter